All right, thank you very much for joining us today. This is the Driving Innovation in Machine Vision webinar with Rendered.ai. And I very much appreciate the folks on the line who've decided to join us. All right, I'm Chris Andrews, the COO and head of product for Rendered.ai. I've got a career based in enterprise domains focused on things like geospatial and AEC technologies, a lot of product management, and some enterprise consulting in my background. And with me is Dylan Harkness. Dylan is one of our fantastic software engineers. He drives a bunch of our simulation development, and he's been doing just a fantastic job at making customers happy in his time at Rendered, which exceeds mine. Dylan, do you want to say hi?
Hey.
All right, thanks, Dylan. Okay, today we're here to talk about accelerating machine vision training in specifically in domains such as manufacturing, logistics, industrial settings. And I've just got a couple of examples up here focused on inspection and assembly and sorting and binning. There are a wide variety of machine vision, computer vision use cases already applied in the manufacturing and logistics world. What we see is common applications of machine and computer vision across these industries, and they typically run into their own flavor of the same problems that we see across other industries as well. Attempts to classify very diverse objects in extremely complex scenarios, sometimes extremely visually complicated environments, sometimes not in manufacturing and inspection. Having unusual context sometimes, needing to collect many images at really high speeds, looking at objects with complex visual similarity. And if you're trying to do all of this stuff with humans, it can be extremely labor intensive, require a tremendous amount of expertise, and can end up being very expensive. What we find across the machine computer vision industries is the data is the limiting factor for AI. In fact, in some cases, there's tons of data available, but the data that is required to train algorithms is still either too expensive to obtain or annotate, or simply impossible to achieve. We typically see two different types of challenges with data. In some cases, the inability to get data or the expense of acquiring data can actually limit cost and time to market. In other cases, and we actually see this especially in manufacturing and logistics, we typically see customers there trying to aim for improving performance, because even shaving a couple of percent of error off of detectors can sometimes mean millions of dollars of improvements in performance. So in these cases, what we typically see is attempts to engineer or to obtain better and better data sets to reduce bias and improve accuracy and detection. The classic workflow that I'm sure everybody on the line with us understands is that typically what customers will do is they will somehow capture hundreds of thousands or even millions of images of the scenario or objects or situations that they're trying to apply algorithms against. They'll then have those images annotated, sometimes manually, sometimes through a semi-automated, often human in the loop process. Then they'll train algorithms, and then they'll deploy them. And at the deployment time, typically most algorithms aren't perfect, and so if there are issues with the algorithm at deployment time, then what most customers will have to do is to go all the way back to the capture point, figure out how to capture additional data that will incur additional expense. We've even heard of customers manufacturing incorrect parts or broken parts or damaged boxes specifically to do things like capture real images of those broken items, and that requires a lot of extra expense, human labor time, and even if you manually manipulate or damage parts, you still will never achieve the infinite variety of possible damage variation that you could actually see in the real world. And this is where Rendered.ai comes in. Rendered.ai is a platform for generating 100% annotated synthetic data that can be used to supplement real data for training and validation. And so as you can see in the simplistic graph that I've got here, essentially what you can do is at the point at which you are training a model or you've deployed a model and you decide that the algorithm isn't working the way you would like, you can actually use Rendered.ai and work with our expert team to generate additional imagery that can be used for supplementing training and for validating existing algorithms. By the way, before I get in too much further, if you do have any questions, please go ahead and open the question and answer panel on the webinar controls and go ahead and type in a question for us. So we focus on helping customers understand how they can use synthetic data to improve their model training. Our platform itself has a user-friendly experience, which has been built for data scientists to easily generate imagery. You can configure things like annotation mapping, the scenarios of objects that you're generating. Dylan's going to actually demonstrate some of this in a little bit. You can even do some things like compare data sets. We provide some tools in our platform for helping data scientists actually compare data sets, both real data sets and synthetic data sets, to understand how they might be similar or different and how that might impact training. We also provide Python SDK for wrapping third-party simulators. We do provide some simulators through our platform, but we have also had customers bring simulators to us. And then we work with standard 2D and 3D content types to help generate imagery. And there are APIs for integrating our platform into automated workflows in the cloud. What we typically see is that customers who successfully adopt synthetic data as part of their model training will essentially arrive at a iterative process in which they'll have one group that sometimes refer to as synthetic data engineers will be setting up simulations and configuration, kind of the universe of configuration that's possible. They'll deploy that using our platform to manage compute. Our public hosted PaaS is in Amazon Cloud. And then a data scientist can actually use the user-friendly interface on our SaaS front end to generate data sets, do some of that post-processing and data comparison that's possible with the platform. And then they can take the data sets into model training, some of which is even possible through Amazon SageMaker integration with our platform. At that point, the data scientists may come back with some things that they want adjusted in the simulation, and they can, in some cases, even do that themselves in the front end in the web front end of the platform. In other cases, they may need to go back to the data engineering team to get some changes to the simulation to basically implement new scenarios or new adjustments in the type of data that's created. And that's where either we can come in and help you out, or your own team can actually do that if they have the aptitude. So Rendered.ai actually provides two basic sets of capabilities. One is we have our public cloud-hosted platform, in which we have the ability to do things like customize scenarios and simulations, create many data sets in the cloud, and then we provide some capabilities for doing post-processing on the data sets, and then ultimately integration APIs and SDKs for integration into other cloud or AI workflows. And as you can see on the top row here, we also provide a wide variety of custom and configured vertical applications. Typically, those are starting points for us to then tailor a channel and workspace, a simulation for the type of data that you actually would need. We have lots and lots of customer examples of synthetic data. In fact, on our platform in the public cloud, we've generated somewhere around 12 terabytes of data for customers over the last few years. The company's been in business for over 5 years, and our cloud platform has been out there for almost 3 years now. As you can see, we touch on some kind of warehousing and inspection, manufacturing use cases. We also have some specialty in remote sensing, including non-visible light sensor domains, which can also be applied in things like manufacturing inspection scenarios. All right, I'm going to hand it over to Dylan, who's going to demonstrate how he set up some simulations for a couple different scenarios and manufacturing on our platform. So go ahead and take it away, Dylan.
Thanks, Chris. So let me start sharing my screen here. So I'll be demonstrating our platform and specifically a couple of our new applications that apply to machine vision scenarios. And first, I'd like to just give a basic rundown of the platform just for new users, just to get an idea of how it works. So here we are on the landing page of our platform. And you can see here, I have a number of different images here showing different workspaces I have for different applications that we have available on the platform. And I got these through using what we call our sample gallery. And I'd say that this is a good place to start for new users once they get onto our platform. As you can see, we have a number of different applications here ready to be used. And users can just press the Create Workspace button, and that'll bring it to their organization, and it'll be all ready to use. So the first workspace I'd like to take a look at is this inspection workbench. And in this workspace, I have a number of graphs that are capable of generating output that would be synthetic sort of production line images, as well as sorts of sorting bins with numerous objects being placed into them. And to get a good idea of what sort of output we'll be getting, let's take a look over at the datasets page. And over here, we have a number of different runs of these datasets, and each of these has images that we can take a look at. This one is a sort of conveyor belt with a number of different wrenches on them. And you'll notice that these wrenches have defects. As you can see, there's paint splotches on this one, rust on this one, some sort of grime on this, or maybe grease. And these were all generated in a 3D environment. And you can see that we have these different defects, but they're also annotated automatically, as Chris has mentioned. All the data that we generate using the platform is automatically annotated, and it's especially useful for users to be able to sort of visualize what they're going to be working with before using in sort of machine learning environments. And so we have 2D bounding boxes here. We've got 3D bounding boxes. As I mentioned, these are all 3D simulated. And so we retain the sort of pose of these different defects automatically, as we don't have to do any sort of calculation of that after the fact. And so that saves some time on post-processing. We also have some instance segmentation here, and I can do some different UI to make it a little bit clearer. We have instant masks as well, and these are generated for all these different images. I can cycle through more generated images from this one data set, and producing these took only a few minutes, and generating and like changing the graphs for these is very simple. And you can see in this other output, I've changed some of the parameters to place the object only in the center. And this is, say, a style that would only be inspecting one object at a time. And so both of these were generated using the same graph with just a minor amount of modification. And so I'll get into that in a moment here, but just want to show a few other sorts of possibilities for what this channel can do. The channel being a term we use for our different applications. And so here's an example of, say, sorts of different objects all sort of placed on the conveyor. And this might be for identifying objects that shouldn't be there, or perhaps a malfunction that's happening in the production line. But you can also see that there's just a lot of variation in what you can produce with this one application, say with this one with different parts and sorts of a different background. And so before I get into too much of that, let's take a look at the graphs, how this sort of stuff is put together. And so we could take a look at this custom asset graph here. And we have a number of different nodes in this graph, but it is fairly simple still. So we first start here on the left with our wrench model. And this model was uploaded to our platform. Just any user can do this. They can go into our assets folder and then upload a model to be used in the graph. And they can do this with however many objects that they'd like. And that can be achieved just through going through our UI to like find the wrench and bring it in. And so it's super simple to add in custom objects. But those custom objects aren't just placed uh, on their own. They can also be modified. Say with this defect modification, this will apply a different sort of defect to this wrench procedurally. It'll use the geometry of the wrench to apply these different defects, and they will be matching to the surface of the object. And so it's very easy to just get into having defect simulation with only a few button presses and uploading of some files. So we have some other nodes in this graph as well. We have a sensor that we can configure. This has a number of different camera properties such as focal length, aperture, and things like that, as well as some visual effects to make it a little bit more realistic looking, such as lens distortion or chromatic aberration. We also have physics-based lighting in the scene using kelvins for the lighting temperature. And so you could go down to like 2000 for a very warm light or up to 8000 for a very cool light. We can just leave it as 6000 for now. And you can see that we have the lighting, which is built around the sensor itself. And that will move if the sensor is moved, which normally it's just positioned in the same location. All these different nodes work together into the create scene. And this create scene node will place the objects onto a surface, which we call the stage. And that can be made of different materials, but you can also supply your own sort of textures if you want a certain background. I'll go into a graph showing that in a little bit here. We already have an HDRI, which can also be supplemented with a custom asset. And then we have some different placement things like the amount of objects that could be potentially placed and how they're placed in the scene, whether you have them like in the center, like I showed before with that wrench, or if they're more towards the edge. And then finally, we render out the image with some different image formats and different pixel widths. So now that you have an idea of how a basic graph works, we can take a look at a more advanced graph, such as this configuration one. And in here, I'm using randomization of these values to generate even more variation, is changing that light temperature, as I mentioned, by plugging in a uniform randomized number into both of these lighting values, changing the size of the defect, or changing how many objects are in the scene. And so even with these regular parameter selections, you can also randomize them, which really increases the amount of output that you can generate. So we'll take a look at a couple more examples out here, and then I'll switch over to some other steps. So one of the neat things you can do with this channel is you can simulate sorting of objects in a bin, and all these objects were physically placed, and so they take a different sort of composition every time that you run the graph. And so you can very quickly get lots and lots of different just sorting of these objects. And it's not just a visual image. It does have bounding boxes for each one of these objects, pose information, instance segmentation. And so objects that are completely occluded won't be factored into, say, the metadata that you get as an output. But this is a very nice way to just be able to get very quick sorting algorithm information from this. And in addition to well-fitting objects like that, since you can do custom objects, you can just put other sorts of things in the bin as well, like these hammers, which don't fit quite as well, but they work just the same as the washers, all segmented. And so it's very easy for users to just put in what sort of objects they'd like to physically drop into a bin and see how they sort of sort themselves out. And so that's most of this channel here. I think I can go into our other channel over here, which is our warehouse channel. And this is, say, after you've done the defects checking, and you want to look at after they're done being on the production line and they are ready to be shipped out. With these uh, graphs, you can generate a large variety of different warehouse scenarios, with all of these boxes being pre-annotated, and that's very useful for being able to uh, train different models on this, and to just it's just kind of impressive to look at, see all these different objects pre-labeled, and you can get all sorts of different views in this channel through the configurable graphs, and the segmentation is still working for all of these. And so combining the two channels that we have, you can see that we're already covering a good bit of the production line and the aspects of different machine vision in uh, product creation. So could take a look at a few more examples here. We have things with see, we had a forklift in one of these. There we go. And so just a lot of different scenarios, and we can take a look at one of the graphs responsible for generating this. And you can see we have lots of different assets that we have put in here to be placed on the floor, and a number of different boxes to be put into the warehouse. And so just lots of different ways to customize the different applications in our platform. And so I think that's all I have to show for these two channels. So I'll give it back to Chris to finish off the presentation.
All right. So yeah, thank you very much, Dylan. That was a great overview of the platform and some of the capabilities in it. So Dylan was able to show off some of the kind of custom simulations that have been built for different inspection use cases, and hopefully you got a sense of some of the diversity that can be created in the Rendered.ai platform, based upon basically the end need for whatever kind of data is required for training models. Rendered.ai is kind of a two-part solution. There is a platform as a service underneath everything that allows you to run customized simulations, which we refer to as channels, in the cloud, perform different operations on data sets, and then actually extract data from the platform for use in other systems. We also integrate with a variety of partner technologies, including things like SageMaker from Amazon, NVIDIA TAL, and then we also have access to simulators from folks like ANSYS, Deers Lab at RIT, Esri, and even Quadradox, a company that makes an X-ray simulator. Generally, we are simulator agnostic. You could bring your own simulator to the platform, just like you are bringing your own use case that describes exactly the kind of data that you need. All right, and so to work with us, what you can do is you can either engage with us. We have a solution team that actually can do anything from generate data to build custom simulations that you could run in our platform. And then, of course, we have our platform, and that operates on kind of a standard SaaS PaaS business model. And then I've seen Efren has had his hand up for a while. Efren, if you want to type a question in, you can do that, or I could also possibly allow you to talk here. But before we do that, I just want to say thank you to everyone who has hung out for the call today. We wanted to keep this one a quick and kind of punchy overview of the platform around some specific use cases, and hopefully it's given you a good impression of what's possible with Rendered.ai.
Yeah, thank you, Chris. Can you hear me?
Yes.
I was hoping if you can talk a little bit about bring your own simulator. I'm a beginner to this, so if you can tell me what does that simulator do, and what is the process of onboarding the simulator?
Sure. I'll give the high level overview, and Dylan might be able to dive into a couple of the details. We have encountered a variety of customers who use things like Blender or Unity or or some kind of rendering system to generate imagery. Ultimately, what we're talking about is generating simulated scenarios from which can be captured imagery that replicates the kind of distribution of pixels that you would expect to get in real world data of captured of that type of scenario. So there are a wide variety of simulators on the market. So, for example, we work with ANSYS. They have a simulator for radar called for CVM, and you can actually wrap that simulator in a Python wrapper that that can be basically encapsulated in a Docker container, and then that Docker container can be deployed to our platform. We provide an open source framework that allows you to kind of connect the simulator and some of the configuration of the simulator into the right kind of the right hooks, so that our platform knows how to drive data generation and annotation of the images that are generated.
Got it.
Dylan,
so the customer of your, sorry, go ahead. Sorry.
Go ahead. No, you're good. Go ahead.
So the customer of yours creates the graph that was earlier shown, creates the scene, and that becomes the input to the simulator. Your platform provides a lot of out-of-box simulators, but you also offer the way for the customers to onboard their own simulators. Just like you said, one could be a hyperspectral simulator, one could be radar, LiDAR, whatever. Right? Is that what it is?
Yes, definitely. In fact, it's great that you mentioned hyperspectral. Planet just launched their Tanager satellites. We actually worked with them for about 18 months during the development of those satellites. And one of the things that we helped them do was simulate synthetic methane plumes so that they could test out algorithms to detect them. They just posted an article today about the fact that their first light imagery capture above Karachi actually happened to capture a methane plume. And so yes, we worked with them to adapt an academic simulator called DeerSig that is run and maintained by the Rochester Institute of Technology into one of these channels, and then basically our team helped build the wrapper for the simulator. We worked closely with the RIT team, and then we actually provided a couple of those kind of initial graphs so that when the channel was deployed to our platform, the Planet Data Science team could just sit down at the front end that Dylan showed and immediately start manipulating graphs, changing parameters, and then kicking off jobs to generate imagery. So, yep, that's exactly how it works.
And just one follow-up on that to close it. So the graphs allow the customer to define all possibilities, the permutations and combinations for objects in the scene, and the simulator creates whatever sensor-specific simulation we want, as you said, the hyperspectral LiDAR and radar. Is that how the division of responsibility is?
It is. You can imagine that the range of diversity possible across sensor domains, imagery types, imagery sizes, scenarios is infinite. So typically what ends up happening is the range of configuration and capability is built into a channel so that you have kind of an appropriate universe of diversity possible with the configuration of the sensor and the scene. And then also we have capabilities such as we have a virtual partition called a volume, and a volume can be added to your workspace. The volume can come with some 2D and 3D content for things like imagery backgrounds or actual 3D objects to put in a scene. And then actually users can add their own content into those volumes as well. So between the channel itself, which kind of contains the universe of configuration possible, graphs allow you to define what a specific job will result in, and then other capabilities such as the ability to bring in your own assets. You can get quite a wide amount of diversity from channels that are really focused around fairly narrow use cases. And so it's, computer vision is, as we said earlier, it's extremely dependent upon the data, and the data typically is being captured around a specific scenario within which you need to solve a problem. And so each channel is basically designed for a specific range of scenarios that help accomplish a particular training problem. All right, unless let's see, I see there are a couple other questions that have come through. So Boris, how difficult is it to generate different kinds of defects on different surfaces and parts? Do you provide services around these? Yeah, it really depends on what kind of surface you're talking about. Just this morning, we were demoing internally a channel that is specifically designed to generate surface ocean water waves and conditions. So there are quite a variety of that's quite different from, say, generating corrosion on a part. It's in some cases it's not that difficult. There are a lot of standard tools in kind of modern 3D content creation capability to generate dents and scratches and corrosion on different parts. We do provide services to help with that, because even though there are a lot of tools and widgets and algorithms for doing that, most of our customers are not 3D experts. So our customer success team, Dylan's a member of the team, that's the kind of thing that they work on. Dylan, do you want to talk about any of the work that you did to help create the corrosion on some of the parts that you demoed today?
Yeah. So with the defects shown in the channel earlier, those were generated in Blender and were designed to be more physically accurate. They were generated using an add-on in this case, but you can also generate them yourself. In this instance, it would be in Blender. With some of our other channels, this one included, you can also sometimes supply just PNGs, different sort of textures to generate defects. Is, say you have an alpha image of a scratch, you could just add that to a graph in one of these channels, and it would apply it to the objects. And as Chris mentioned, generally what we do is we work with customers to make sure that we're matching the domain they're looking for, the sorts of defects that they are seeing. And that could be either through things that you can see in the images here, like stuff applied to the outside, or it could be deformations of the mesh itself through sorts of warping or just various dents that could be applied, or actual like gouges in the material. And so implementing those generally is a fairly quick process for our team, and it can be pretty simple for users as well to get their own sorts of defects in there. And so I would say that it is not terribly difficult to generate different kinds of defects in these sorts of channels.
Thanks, Don. All right, any other questions for us before we wrap up? All right. Well, thanks very much, folks, for attending today. It was definitely our pleasure to be able to speak with you, and we appreciate the time. If you have any follow-up questions, you can reach us at, you can reach me at chris@rendered.ai or Dylan, D-Y-L-A-N, at rendered.ai. The easier thing to do is to email I guess sales@rendered.ai, and then it'll make it to us anyway. If you're interested, we have a YouTube channel where we have posted a variety of webinars and other presentation content, including more deep dives into setting up channels and configuring graphs. You can find that on our website, rendered.ai.com. And then you can even sign up and actually try a free trial and actually select one of those workspaces that Dylan showed in the sample gallery right after you sign in for the first time. No credit cards required or anything like that. So we're happy to have folks try it out. So after that, I'd say if you have any other questions for us, please let us know. We definitely thank you for your time, and we hope you have a good rest of your day. Thank you.
Thanks.